Good day, everyone. My name is Shazur Hasri bin Shamsuddin, and I will present the summary of my research entitled The Synthesis of AUP.RGO for Simultaneous Heavy Metal Detection. For introduction, natural phenomenon like volcanic eruption causes leaching of heavy metals into lakes, rivers, and oceans. To make matters worse, human activities such as smelting and mining has significantly increased the concentration of heavy metals in nearby water bodies, which eventually pollutes the environment. Heavy metals is non-biodegradable, hence the metal ion will bioaccumulate inside bodies of aquatic organisms and subsequently biomagnify through the food web. Once consumed by humans, various health problems will occur with respect to the type of exposure. For instance, acute exposure causes vomiting, while chronic exposure causes cancers. There are limitations on using spectroscopy technique to detect heavy metal. For example, it is expensive and unsuitable for in situ measurement. Fortunately, other alternative is by using electrochemistry, in which differential pulse voltammetry is the technique. To further enhance the detection of analyte, working electrode will be modified with ternary nanocomposite. The material chosen are RGO, P dot, and gold nanoparticles. The justification for selection of RGO is because it have excellent thermal conductivity. P dot have high electrical conductivity, while gold nanoparticle is able to enhance the electron transfer between electrode surface and electrolyte. The objectives of this research are to synthesize AUP.RGO for simultaneous detection of heavy metals. Next, to characterize AUP.RGO using SEM-EDS, Raman spectroscopy, TGA, CV, and EIS. Last one is to investigate the electrochemical behavior of heavy metals utilizing AUP.RGO modified on GCA using DPV analysis. For the synthesis of AUP.RGO, firstly, gold, ethanol, and E dot were mixed in a beaker, then stirred for 4 hours. Next, GO dispersion was added into the solution. The third step was to sonicate the solution for 2 hours. Then, reducing agent was added drop by drop using a dropper while stirring. The solution was left for 6 hours while stirring. The solution was centrifuged using ethanol and the ionized water. Dropper was used to remove excess deionized water. Finally, the precipitate was dried at 60 degrees Celsius for 12 hours. For drop casting of AUP.RGO, firstly, set up a hairdryer on retort stand. Then, clamp the working electrode below the hairdryer. Lastly, drop the composite slowly using micropipette and let to dry from low to high speed. This is the SEM image of AUP.RGO. The morphology observable is the reduced graphene oxide sheet, which have wrinkle or flakes on the surface. Since we cannot indicate the presence of gold using SEM, EDS analysis was performed. EDS analysis for AUP.RGO confirmed the presence of gold in the composite, in which gold have the highest percentage mass compared to carbon, oxygen, and sulfur element. In overall, the thermogram showed that all synthesized composite exhibit two decomposition regions, besides started to lose some mass below 100 degrees Celsius due to evaporation of adsorbed water. Focusing on AUP.RGO depicted by the green line, 23% of mass loss has takes place at 350 degrees Celsius at the second stage. This loss of mass can be attributed to the polymeric decomposition of P dot. For Raman spectroscopy, all synthesized composite have the D and G peak, which indicates the presence of defects. In other words, all nanocomposite is successfully synthesized. Observing the AUP.RGO, it exhibits much higher peak intensities compared to other nanocomposite, which reveals strong coating of ligand in between AU nanoparticles, P dot, and RGO. Based on the CV obtained in ferrocyanide system, it can be clearly seen that AUP.RGO have the highest current peak compared to other composite. Thus, the result proved the ability of AUP.RGO to enhance electrical conductivity. Meanwhile, the Nyquist plot shows that AUP.RGO have the lowest RCT than other composite. This means that the electron experience less resistance during its transfer from electrolyte to electrode surface. DPV measurement further proves the great ability of AUP.RGO as the sensor successfully detect all heavy metal ions simultaneously. Plus, it have a much higher current peak than bare GCE. Hence, the redox process of analyte occurs effectively using AUP.RGO. In a nutshell, AUP.RGO is a promising nanomaterials as sensors. It is able to promote electrochemical reversibility, ensure effective electron transfer, while enhance the electron transfer kinetics between analyte and electrode surface. Thank you.